going to talk about the conic section called an ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. So an easy way to show that is with this. These two tacks here are going to play the role of the two fixed points. We call each one a focus. That's going to be a focus right here, and this will be our other focus right here. The string represents the sum of the distances. So if I grab my pen right here, the sum of the distances will be a constant because the sum of the distances is however long that string is. So I'm going to find all the points, the sum of whose distances is the length of that string. So I can move my pen around. Let me move it the other direction over here. I've got to move the string on the other side so I can draw the other half of the ellipse. So let me take these out so we can see them. See the graph? There's our ellipse. This point is a focus and this point is a focus, and we have our ellipse. This axis right here is called the major axis. It's the longer of the two axes, and the distance across here, or this segment here, is called the minor axis. So let's look at how we come up with the equation for an ellipse using that definition. So I'm going to orient the ellipse this way on the Cartesian coordinate plane. And I'm going to put the foci, that's plural for focus, here at C and at negative C. So the center for our ellipse will be at the origin. Now we know that the equation of the ellipse will be the equation generated by the sum of these distances being a constant. I'm going to call this distance 1 and this distance 2. And this point right here will just be some generic point xy. And of course, since this is at C on the x-axis, we'll call it C0. And this point over here, negative C0. So we want the sum of those distances to be a constant. So D1 plus D2 is some particular constant. On my example, the constant was the length of the string that I had. Well, it turns out that the algebra works really nicely if we let that constant be 2a. So we have distance 1 plus distance 2 equals 2a. Now distance 1 is the distance between these 2 points. So we use our distance formula. Square root of x minus negative c squared plus y minus 0 squared. Well, y minus 0 is a lot like y. Plus the square root of x minus c squared plus y minus 0 squared, again, is just y squared. And that equals the constant 2a. Now here's where I'm going to leave about, about 8 steps out. You could look in almost any book that talks about ellipses and generating the equation, and you can see what happens in here. It's kind of fun. I just don't want to take the time to do it. You isolate one radical, square both sides, isolate the radical, square both sides, manipulate it algebraically, and what happens is you end with this. X squared over a squared plus y squared over a squared minus c squared equals 1. And we make a substitution for this a squared minus c squared. We just let a squared minus c squared equal b squared and make that substitution right here. So we have x squared over a squared plus y squared over b squared equals 1. With this relationship between a's, b's, and c's, I prefer to rearrange it so that I have the a squared minus b squared equals c squared. So here's the relationship between a, b, and c, and here's our equation of our ellipse. Now let me draw that ellipse for you. This particular one, because I didn't draw it here. So here's the equation we're talking about. Let me rewrite it. It's x squared over a squared plus y squared over b squared equals 1. Given that a squared minus b squared equals c squared. Well, if you were going to graph this, you can easily find the x-intercepts by making the y value equal to 0, and eliminate this term, and you would have x squared over a squared equals 1. That a squared will just be a number, so you would have x squared equals a squared. So x equals, and you take the square root of both sides, and you'll have plus or minus a. So if I'm graphing this, I would come over here on the x-axis to a and to negative a. Similarly, finding the y-intercepts, you make x 0, and you would be solving y squared over b squared equals 1. So when you solve that equation, you have y equals plus or minus b. So I can go in the y direction, b units. And down here to negative b. So our ellipse would look something like this. So here's the way the graph looks for x squared over a squared plus y squared over b squared equals 1. And let me mention again, this axis right here is called the major axis. And this axis right here, the shorter of the two axes, is called the minor axis. And the focal points are always on the major axis, c units from center. So the focal points could be about right here or here, c units away from center. If we orient the ellipse the other direction so that the major axis is vertical, here's the way the equation would look. It would be x squared over b squared plus y squared over a squared equals 1. Again with a squared minus b squared equaling c squared. This time, if you found the x-intercepts, we would find that they're at b and negative b, and the y-intercepts are at a and negative a, and our ellipse would look something like this. Now from these equations, you can't really tell the difference between the a squared and the b squared, but let me just tell you, with respect to the ellipses, we let a squared be the larger of the two denominators. So if the larger of the two denominators is underneath the y squared, you'll have a vertical ellipse like this. If the larger denominator is underneath the x squared, you'll have a horizontal ellipse like this. So on this one, again, the focal points will be on the major axis being the longer of the two axes. So for this particular problem, This is the major axis. And the minor axis is horizontal right here. And again, the focal points would be along the major axis. So I know they would be up here at C and down here at negative C. So those are the two types of ellipses we'll be working with, horizontal one or vertical one. So let's do a problem. So let's look at x squared over 25 plus y squared over 9 equals 1. We're going to graph it and find the focal points. So we're going to graph and find the foci. So this one, excuse me, is centered at the origin, like the two examples I gave you already. On our next one, I'll show how it shifts off the origin. But I look underneath the x to figure out how far to go in the x direction. So here's my graph. I'm going to go in the x direction, the square root of 25 units, in other words, 5 units. So let's just jot down that a squared equals 25. That means a equals 5. Here's 5 and negative 5. B squared, the smaller of the two denominators, is 9. So in the y direction, we're going to go 3 units. So up to 3 and down to negative 3. And then I draw my ellipse. Sometimes I find it easier to draw if I rotate my paper this way. Just easier for me to draw it in that direction. But you don't have to. But I've just found that's what works best for me to draw a decent picture. So there's my ellipse. And this again is our major axis. This is our minor axis. The endpoints of the major axes are called the vertices. Sometimes you call the endpoints of the minor axes the co-vertices. So to find the focal points, remember they will be on the major axis. So they're here and here somewhere. So to find those foci, I know it's a squared minus b squared equals c squared. C squared. I already jumped to the number. So we have 25 minus 9 equals c squared. So we get c equals plus or minus 4. So from center, we go 4 this direction and 4 this direction. So our foci are at 4, 0 and a negative 4, 0, right here and here. And our problem is done. Let's do one more. This time we're going to graph x plus 5 squared over 4 plus y minus 1 squared over 36 equals 1. And the directions are still going to be the same. Graph and find the foci. So this time it's been shifted off the origin, and fortunately you can find center much like you do when you find center for a circle. It's x minus the x coordinate of the center and y minus the y coordinate of the center. So the center for this one is negative 5, the opposite of the number you see there, and 1, the opposite of this number that you see here. So if I'm going to graph this, my center will be at negative 5, 1. So negative 1, 2, 3, 4, 5, 1. So there's my center. Now I can look underneath the x squared to find out how far to go in the x direction. My a squared, let's jot this down, my a squared is the bigger of the two, 36. My b squared is 4. We'll just jot that down for later. But underneath this x squared expression, we have b squared. It tells us how far we're going to go in the x direction. Take the square root of that number. So we're going to go 2 units from center, 1, 2. Here's a point. I'm at -3. And 2 units this direction. I'm over here at -7. And in the y direction, I take the square root of this number and I'm going to go up 6. So here at 1, I'm going to go up 6. That put me at 7. And I'm here at 1 and I'm moved down 6. Where would that put me? At -5. So I have my center at -5, 1. I can see my major axis is vertical. My minor axis is horizontal. I'll do my best to draw a nice ellipse through these points. Again, I'm going to rotate my paper as I draw it. Makes it a little bit easier for me. And it should be smooth. That one looks a little bit too pointy right here. It is always a smooth curve for your ellipse. So it looks like that. There's my picture of my ellipse. Now my foci are on the major axis. So they are on here somewhere, up here and down here. Let's find them. We know it's a squared minus b squared equals c squared. So a squared is 36, b squared is 4. So I know 32 equals c squared. So when we take the square root, we have plus or minus the square root of 32. We can simplify that, right? That's 16 times 2, so 4 square root of 2. So our c value is 4 square root of 2. I leave that plus or minus in. To remind you, we go up 4 square root of 2, and we go down 4 square root of 2. So from the point -5, 1, we go up 4 square root of 2. That means we're adding 4 square root of 2 to this 1, to the y value. So this point up here would be -5, 1 plus 4 square root of 2. And similarly, this point down here would be -5, 1 minus 4 square root of 2. And those are the foci for this problem. -5, 1 plus 4 square root of 2, and -5, 1 minus 4 square root of 2. And we finished this problem as well.